Hello students, in this lecture we will discuss how to identify oxidation as well as reduction reaction in an electrolysis process by using standard oxidation potential and standard reduction potential. By using standard oxidation potential and standard reduction potential. Let me write it on the board. We have standard reduction potential. Next is standard oxidation potential. Standard reduction potential in short form is known as SRP, and standard oxidation potential in short form is known as SOP. Okay, SRP standard reduction potential, SOP standard oxidation potential. Okay, always keep in mind in any chemical reaction, elements having larger value of SRP, SRP means standard reduction potential. Elements having larger value of SRP will have a greater tendency to show reduction reaction and act as oxidizing agent. Very interesting information we have. You can see elements having larger value of SRP will have greater tendency to show reduction reaction and act as oxidizing agent. As the SRP value increases, tendency to act as oxidizing agent also increases. Okay, now opposite to it, elements having a smaller value of SRP will have a greater tendency to show oxidation reaction and act as reducing agent. Very simple information is there. Very simple information. Okay, when a couple of chemical reactions are given there with their SRP values, by using this condition we can easily identify whether the oxidation reaction is there or reduction reaction is there. Okay, larger the value of SRP, greater is the tendency to show reduction reaction. Lower is the value of SRP, greater is the tendency to show oxidation reaction. Okay, now let me talk about SOP. Okay, larger the value of SOP, standard oxidation potential, elements having larger value of SOP will have a greater tendency to show oxidation reaction and act as reducing agent. Okay, elements having lower value of SOP will have a greater tendency to show reduction reaction and act as oxidizing agent. This the information is there. Okay, so whether the SRP values are given there or SOP values are given there, by using these conditions we can easily identify oxidation as well as reduction reaction. Let me take some example. Okay, now pay attention very carefully. We have a half reaction Ag plus and this is silver. Okay, for this half cell reaction we have electrode potential value that is 0.80 volt. Okay, E naught is given there, then we can say it is standard electrode potential value. Okay, next half cell reaction Fe3 plus and then we have Fe2 plus. E naught cell value for this is given 0.77 volt. Now pay attention very carefully. You can see in these two equations we are not given whether these values are SRP values or SOP values. Okay, whether these values are SRP values or SOP values, only E naught cell values are given there. No problem, by looking at the equation we can easily identify whether these values are SRP or SOP. Pay attention very carefully. This silver ion is present in +1 oxidation numbers. This is neutral element, that's why it will have 0 oxidation numbers. Okay, if you compare the oxidation number of these elements, you can see +1 to 0, decrease in oxidation number, and decrease in oxidation number is always reduction reaction, and increase in oxidation number is always oxidation reaction. Okay, since reduction reaction is given here, it means reduction potential value is given here. Okay, E naught means standard reduction potential. We have SRP value. This is SRP value. Okay, now move on to the next equation. Iron has +3 oxidation numbers, other side it has +2 oxidation number, +3 to +2. Decrease in oxidation number means reduction. It is also a reduction reaction, hence we can say it is also a SRP value, standard reduction potential. Both are SRP values given. Now by looking at this value we have to identify oxidation as well as reduction reaction. Now pay attention very carefully. You can see larger the value of SRP, elements having larger value of SRP will have greater tendency to show reduction reaction. You can compare these values. 0.80, 0. 0.80 is larger than 0.77. That's why in this case this reaction is reduction reaction, and this is lower value. Elements having lower value of SRP will have greater tendency to show oxidation reaction, then it is oxidation reaction. Okay, Ag plus ion is having greater tendency to show reduction reaction. Why? Because it is having larger SRP values. Okay, by looking at the values, by using these conditions, easily you can identify oxidation and reduction reaction as well as oxidizing agent and reducing agent. Let me take some more examples. I have written a question on the board. You can see the question says given the standard electrode potential values are given. You can see these are the half cell reactions given. Standard electrode potential values are given. Question does not specify whether these values are SRP values or SOP values. By looking at the reaction, we can identify. Pay attention very carefully. You can see potassium ion, it is present in +1 oxidation number, and this is what? Single element, neutral element. That's why it is present in 0 oxidation numbers. We can compare the oxidation number +1 to 0, decrease in oxidation number, and decrease in oxidation number is always reduction reaction. So since it is reduction reaction, then we are given reduction potential value. If it is oxidation reaction, then it will be what? Oxidation potential value. So you can see reduction reaction, reduction potential value. SRP, we can say standard reduction potential values are given. SRP values given. Move on to the second equation. Okay, Ag plus 2 Ag0, +1 to 0 reduction SRP value, +2 to 0 reduction SRP value, +2 to 0 reduction SRP value, +3 to 0 reduction SRP values. Okay, now pay attention to the question. Question says arrange these metals in the increasing order of their reducing powers. Okay, so since SRP values are given here, and we have learned related to SRP values, elements having larger value of SRP will have greater tendency to show reduction reaction and act as oxidizing agent. Okay, next statement is there. Elements having lower value of SRP will have greater tendency to show oxidation reaction and act as reducing agent. Very simple information. Okay, now pay attention very carefully. Look at the question. It is asking increasing order of reducing powers. You can see as the SRP value decreases, their reducing power increases because their tendency to show oxidation reaction increases. So since we have to arrange these metals in the increasing order of reducing power, then we can arrange these metals in the decreasing order of their SRP values, because as the SRP value decreases, their reducing power increases. Very simple concept. Okay, now pay attention here. It is negative, positive. This is positive, negative. We have negative values. These are the two positive values. So this is the largest value we have. We have to arrange these SRP values in the decreasing order so that their reducing character should increase. So this is the largest value we have. Ag plus is having largest value. Okay, after this we are having Hg2 plus, and then we have the negative values, negative. Then we have Cr3 plus, and then we have 2.9, 2.3. Then we get Mg2 plus, and then we have K plus. This is K plus. You can see we have arranged these metal ions in the decreasing order of SRP value. SRP value is decreasing from left to right, and as SRP value decreases, their tendency to show oxidation reaction increases, and their tendency to act as a strong reducing agent increases. Okay, so their reducing power is increasing from left to right. So very simple concept is there. So you can see to answer this kind of questions, we use only this statement. Okay, as the SRP value decreases, their tendency to act as a reducing agent increases. Okay, now let me take one example related to standard oxidation potential. The next question is on the board. You can see the question says identify the increasing order of oxidizing power of these metals. Okay, oxidizing powers. Now first of all, you can see we identify whether these values are SRP values or SOP values. Pay attention very carefully. Look at the equation. Okay, So you can see this is NO, nitrogen is plus 2 and in this case nitrogen is what, plus 5. Okay, you can calculate the oxidation number by using oxidation rule. So you compare the oxidation numbers, it is plus 2 and it is what, plus 5, plus 2 to plus 5, increase in oxidation number. And we have learned when oxidation number increases, it is always oxidation reaction. Increase in oxidation number is always oxidation reaction and decrease in oxidation number is always reduction reaction. Okay, plus 2 to plus 3, increase in oxidation number, oxidation, then it is oxidation potential. 0 to plus 2, oxidation, oxidation potential. 0 to plus 3, oxidation, oxidation potential. 0 to plus 1, oxidation, oxidation potential. 0 to plus 1, oxidation, oxidation potential. You can see in all these reactions only oxidation is taking place, that's why oxidation potential values are given, standard oxidation potential values. Okay, now related to oxidation potential, related to standard oxidation potential, we have learned elements having larger value of SOP, SOP means standard oxidation potential, elements having larger value of SOP will have a greater tendency to show oxidation reaction and act as reducing agent, and elements having lower value of SOP will have greater tendency to show reduction reaction and act as oxidizing agent. Very interesting concept is there. Okay, it means as the SOP value decreases, their oxidizing powers, their character increases. Okay, so you can see we can write down these SOP values, in the decreasing orders, because as the SOP values are arranged in the decreasing orders, then the oxidizing power of these metals will be increasing. Okay, now pay attention very carefully. We find out the largest value because we have to arrange these values in the decreasing orders. Negative, negative, negative. Okay, and then we have these are the 3 positive values. Out of the 3 positive values, which one is the largest value? This is 3.05, this is 2.7, 0.7. Okay, this is the largest value we have. Then we can write lithium. Lithium is there. Okay, now we are writing these metals having SOP value in the decreasing orders so that their oxidizing power is increasing. Okay, then we have a sodium, and then after this we have CRs. Okay, then we talk about negative value, minus 0.34, minus 0.77, minus 0.97. Then we will have a 4th one, 5th one and 6th one. Then we have coppers, then we have Fe2 plus, very simple concept, and then in the last we have NO. If you look at here, you can see SOP value is decreasing from left to right, and as SOP value decreases, their tendency to undergo reduction reaction increases, and their tendency to act as a strong oxidizing agent also increases. Okay, oxidizing character increases as the SRP value decreases. No, sorry, SOP value. Okay, we are talking about SOP value. Okay, so you can see very interesting concept is there. By using this statement we are able to answer this question. Okay, lower is the SOP value, higher is the tendency to undergo oxidation reaction and act as stronger, no sorry, higher is the tendency to undergo reduction reaction and act as oxidizing agent. Now we discuss how to calculate electrode potential in a complete cell reaction. For a redox reaction, we can say complete cell reaction is what? Redox reaction. So now we are going to calculate electrode potential for the complete cell reaction, means for the redox reaction. The next question is related to standard electrode potential. Okay, the question says calculate the standard electrode potential for the following cell reaction. This is a complete cell reaction, means it is a redox reaction. We can identify if it is a redox reaction or not by writing the oxidation number of atoms on both sides of the equation. You can say single element is 0, oxidation numbers. It is monoatomic and its charge is equal to its oxidation numbers. Monoatomic and plus 2 oxidation numbers. Neutral element 0 oxidation numbers. We can compare the oxidation number of same elements. 10 to 10, 0 to plus 2. Increase in oxidation number. Increase in oxidation number is always oxidation. Decrease in oxidation number is always reduction. You can see it is undergoing oxidation. Okay. Now silver to silvers. Plus 1 to 0. Decrease in oxidation number is reduction reaction. This is reduction reaction. It is oxidation reaction. Okay. So it is a chemical reaction in which both oxidation as well as reduction reactions are taking place simultaneously, then we can say it is a redox reaction. Okay, for this redox reaction we have to calculate standard electrode potential. The formula we have E naught cell is equal to E naught cathode minus E naught anode. Okay, there are two electrodes in electrolysis process in an electrolytic cell. Okay, one is cathode, another is anode. At anode, oxidation reaction take place, oxidation, and at cathode, reduction reaction takes place. Okay, when we have to calculate the standard electrode potential for an electrolytic cell, standard electrode potential is the potential difference between the two half cell reaction, between these two half cell reaction. Okay, we have to find out the potential difference. Okay, that's why we have the formula standard electrode potential is equal to standard electrode potential of the cathode reaction minus standard electrode potential of the oxidation reaction. Very simple concept. Okay, we can write this formula this way also. E naught cell is equal to at cathode reduction reaction take place, E naught reduction we can mention, and at anode oxidation reaction take place, we can write oxidation. This is the formula we have. Now you can see, since tin is undergoing what? Oxidation reaction, then we can say this is what oxidation value. Silver is undergoing reduction, then we can say it is reduction value. Okay, reduction value, we can plug in the values in this formula, we can calculate the standard electrode potential values. Let's say assume this equation is not given in the question. Okay, only this data is given there. By looking at this data also we can identify oxidation as well as reduction. Now you can see, pay attention very carefully. First of all, we identify whether these values are SRP value, SOP values. Look at here, +1 to 0 reduction potential, +2 to 0 reduction potential. We are given reduction potential, means standard reduction potential values are given. Related to SRP, we have learned as the SRP value increases, tendency to show reduction reaction increases. Tendency to show reduction reaction increases. As SRP value decreases, tendency to show oxidation reaction increases. Okay, now we can compare the values. This is 0.80 and this is minus 0.14. Higher the SRP value, higher is the tendency to show reduction reaction. Compare these values. This is the larger value, that's why it will have greater tendency to show reduction reaction. Written already. Lower is the SRP value, greater is the tendency to show oxidation reaction. We can see oxidation because this is lower SRP value. Okay, so in case even if this chemical reaction is not given in the question, by using this data we can calculate standard electrode potential. Okay, apply the formula. E naught cell is equal to reduction, E naught reduction we have 0.80 and minus, then we have E naught oxidation. E naught oxidation is what? Minus 0.14. Simplify, 0.80 plus 0.14, it is 0.94 volt. Okay, so for this overall net cell reaction we have standard electrode potential value 0.94 volt. Okay, always keep in mind it is the potential difference between half cell reaction, between these two half cell reaction. Okay, now next we discuss how we can identify if the cell reaction, if the redox reaction taking place in electrolytic cell is feasible reaction or non-feasible reaction, is spontaneous by nature or non-spontaneous by nature. Let's discuss. The next question is related to the feasibility of a redox reaction in an electrolytic cell. Okay, the question says, using the standard electrode potential, find out the pair between which the redox reaction is not feasible. How we can determine if the redox reaction is feasible or non-feasible? Okay, spontaneous by nature or non-spontaneous by nature. Always keep in mind, for a cell reaction taking place in an electrolytic cell, if E naught cell value is coming positive, okay, when we calculate standard electrode potential by using the formula, E naught cell is equal to E naught reduction minus E naught oxidation. And if E naught cell value is coming positive, that reaction will be feasible by nature, or we can say spontaneous by nature. Okay, if E naught cell value is negative, that cell reaction will be non-feasible. Remember, very simple information. Okay, or we can say non-spontaneous. Okay, now we can say these are the half cell reactions given there, and so we have to make pair one by one. Okay, and so we have to identify if these reactions are feasible or non-feasible. First I take first reaction and second reaction. Okay, these are the half reaction. Okay, so by first of all we identify SRP SOP value. You can see +3 to 0 reduction potential, 0 to -1 reduction potential, +2 to 0 reduction potential. We are given SRP value. In case of SRP value, we have learned higher is the SRP value, greater is the tendency to show reduction reaction, and lower is the SRP value, greater is the tendency to show oxidation reaction. That's what we have learned. Okay, now pay attention very carefully. You can see this is 0.77 and this is 0.54. This is the larger value, then we can see it is reduction. Larger is the SRP value, greater is the tendency to show reduction reaction. This is the lower value, lower is the SRP value, greater is the tendency to show oxidation reaction. Okay, now we can apply electrode potential formula, standard electrode potential formula. E naught cell is equal to E naught reduction minus E naught oxidation. Plug in the values. E naught reduction 0.77 minus E naught oxidation value 0.54. Simplify, it is 3 and it is 2, 0.23. Okay, 0.23 volt. This is the positive value. And if E naught cell value is positive, then reaction will be feasible by nature, means spontaneous by nature. Now I make another pairs. I take the second equation and third equation. Okay, so now compare the values. This is 0.54, this is 0.34. This is the larger value, then it will undergo what? Reduction. This is the smaller value, then it will undergo what? Oxidation. Okay, now apply the formula. E naught cell, very simple concept. Larger value, E naught reduction 0.54 minus E naught oxidation 0.34. Simplify, we have 0.20 volt. This is also a positive value, means this reaction is also feasible by nature. Now I take another pair. I take third and first half cell reaction. Okay, so now you can compare. You can see this is 0.77 larger value, this is the smaller value. So since it is larger value, it will undergo reduction. Since it is a smaller value, smaller SRP value, then it will show oxidation reaction. Okay, so we have the formula E naught cell. You can E naught reduction 0.77 minus E naught oxidation 0.34. In this case, you can subtract 4, 3, 7, 3 is there, answer 4 is there, 0.43. Okay, 7 is there. 0.43 volt, it is also a positive value. Okay, it is also positive value. You can see for each pair we get standard electrode potential value positive. That's why each pair is going to make feasible reaction. Okay, feasible reaction means spontaneous by nature.